I'm Lydia. This course is designed to cover briefly the most important concepts of Git, and then we focus on GitHub. We address many other aspects of GitHub, such as conflicts and code sharing with Git. At the end of this course, you will be able to master Git and the hosting service GitHub, as well as its many features. We will start with the basic concepts of Git. There will be a quick installation version of Windows and Mac, and if you want more details about that, you find them in the bonus section. Once you have understood Git and installed all the necessary tools, we will begin with the basic commands of Git. And as we progress through the basic commands, you will learn how to create your first Git project. After learning the principles of Git, we will cover more advanced topics such as comparison, branches, and merge. We will deal with many other Git features, and the majority of them are of backup. We will work with the repositories and how to join projects on GitHub and contribute to these projects. After covering the main aspects of GitHub, we will see some of the other features such as code sharing with Git, conflicts management, and the grouping of repositories by organization. Hello, I'm Lydia. During this course, we often use the command line, but also other methods such as the graphical tools and web interface. In the beginning, we focus on the command line. We will start with the command line for these reasons. Firstly, there is a long history with Git command lines. Git was originally designed as a command line tool, and the graphical clients came later. Moreover, and as a result, the new features are integrated into the command line before being integrated into a graphical client. Finally, online researches, websites, blogs, and so on. These tutorials mainly use the command line to communicate about how Git works. That is to say, you may often have problems or omissions, or at least you may need to do researches to answer your questions. In addition, the command line has more power. Graphical clients implement only the main and commit commands, but leave out very powerful options, for example, those of Windows, Mac, Linux, and large platforms. I will enter my command in Git that is specific to a platform. Besides, the command line is back into popularity with new development tools focusing on the command line interface. Getting comfortable with the terminal has a real interest. Once you understand how Git works, you can use graphical clients. There are many options including excellent IDE integration. Learn Git first through the command line and then add the graphical tools later. Git is a decentralized or a distributed version control system. Although Git is decentralized, most people still choose to use a central server as a primary repository for a team project. Another advantage of the distribution is that most operations of Git are local. Only few commands require network connection. Otherwise, you can work completely disconnected and even make comparisons and commit without being connected to a network. Since most of the operations are local, Git is very fast for these same operations. Git is the most popular. Version-controlled files awaiting management and their history are considered as a repository. While we usually consider a collection of files and folders during merge as a repository, in fact, a repository is rather a history of files. Normally, in the root folder of your project, there will be a Git folder, a folder containing the repository. The Git folder contains its own collection of files and folders that constitute the internal structure of a repository. Since a repository contains the entire history of all files stored in it, I advise you to keep your Git repositories as targeted as possible. For example, one application may have a Git repository for the front and another for the back. Each application should be in its own repository and, if possible, not shared with other applications. Version-controlled files await. Git works by recording the current state of all its files that generate in commits. A commit can contain one or more file changes. It's important to note that Git versions are files, not folders. You may sometimes have to use a technology that requires the existence of certain folders, so you can create empty dummy files to force Git to keep the folder. When you make changes, commits are saved on the timeline called a branch. A Git repository will normally have at least one branch, and by default that branch will be called master. Additional branches can be created, but I will deal with this later on. Our initial work right now will be focused on the main branch. You have to know the three local states of files managed by Git. We have the working directory, the staging area, and the Git repository, or the commit history. The working directory contains all the files and folders of your application that may be tracked or not by Git. Anyway, Git knows about all its files. And on the other side, we have the Git repository, or the commit history, that contains all the modifications that have been committed or recorded in the Git repository. Moreover, the intermediate area, or the staging area, is used to prepare for the next commit. The files are moved from the modified working directory state to the Git staging area, and then finally committed in the Git repository. These three Git states are specific to the local Git repository. There is also a remote state. Although a remote repository is another repository with these three internal states, I consider it as a fourth state, as most users do not consider something really recorded until it has been saved or shared on a remote server. I will explain and give more details about the remote repository later on. For now, we focus on the three local states of Git. You have to know In this video, we will continue with our demonstration repository by adding files and checking the status as we go. We start by coming back to our project folder and then to the test folder with the commands cd projects, like this, and cd test. Each time you want to know what's going on in our repository, you can use the git status command. We are preparing for the commit. We can see that we are on the branch master. Nothing has changed because we haven't added anything yet. So let's do it. Let's create a file. Don't hesitate to use the text editor you configured with your command prompt. So I will type touch. I leave a space and the name of my file, for example, hello.html, like this. Now that we have created this new file, if I type ls, like this, we can see the file called hello.html. With my text editor, I'm going to add a short text, like this, h1, hello, and a paragraph, for example, hi. After saving the text in your file called hello, we are going to run a git status command. Now, there is a difference. Git tells me that I'm still on the initial commit and that I have untracked files, and it also tells me what I should do, which is performing git add command and the name of my file. This moves the file hello from its location in the working directory to the git staging area. So I will type git add and the name of my file, for example, hello.html. Now that our file called hello is in the staging area, we can check with the git status command. like this. Now, Git tells us that we will have changes to commit, which means that the file is in staging area. The next step to do is commit. So type git commit, and for this first example, I will use the option -m followed by a commit message in quotes, which is first test, as you can see. So although we have a response from Git, it tells me that I have a file and 3 insertions. It gives me an identifier of the root commit. This means that we have modified a file, which is the one we created with 3 insertions. Then it is found in the command prompt. Now, if I run a git status command, I'm still on the master branch. I have nothing more to do because I'm in an empty working directory. Hello, I'm going to show you the workings of Git repositories. We will start by doing ls-all like this. I'm currently in the test repository, and we have the file named hello, which has been committed. What is interesting is that this specific folder, I mean the test project folder, is the working directory of our current Git repository. This current repository is contained in the .git file. If I change the directory in the .git file, then it will be cd.git, like this. My command prompt warns me that I'm in the Git directory. It's a specific Git directory that handles internally. It contains several files and folders used and managed exclusively by Git. I highly recommend not to open the .git file unless you know exactly what you are doing. Now that we have finished examining this question of the .git file, let's come back to our working folder with the command cd and 2 dots, like this. As you can see, we come back to the test project. To show that our Git repository is entirely contained in the .git folder, I will delete the .git folder completely. You can use the command rm-rf and the file name .git, then press enter. Our command prompt deletes the master because we have no more Git repository. Now, if I type ls like this, I have only the file hello and not the .git one. If I run a git command, such as git status command, Git will respond that this is not a Git repository. We will continue by adding files to our newly recreated test repository. As a reminder, we have now one untracked file, which is hello.html. Before adding it and continue to commit, let's add another file. Let's create a file, for example, venus.html, by using the command touch. So we type touch venus.html like this, and then press enter. For now, I will just put a text here. Once you have put a text here, save and then close. Back to the terminal, run a git status command. And now we have the files hello.html and venus.html not tracked. Now I'm going to add these two files, and at the same time I will use the command git add all like this. I use the parameter all to indicate that all the files of this current folder are added to the git staging area. Now let's execute a git status command. We can see that the two files have been added to the git staging area. Let's go ahead with a commit. However, this time, instead of specifying the option -m to add a commit message in a direct line on the command prompt, I will just type git commit, like this. This will make the main editor configured with Git be used. Concerning the commit message, press Enter. This commit message will consist of several lines, adding the file hello and the file Venus to the repository. Use simply the function save of your text editor with, for example, Ctrl+S and Ctrl+W to close the editor. Then Git uses what you typed in your text editor as a commit message. We will continue by adding files to our newly recreated test repository. In this video, I'm going to show you the commit history with git log. I'm currently connected to my terminal in the test repository. If I run a git status command, as we have just done a commit, we have a clean working directory, so there is nothing to commit. To show you that all the changes we have just made are in the git repository, we can use the git log command to get our list of commits. If I type git log like this, press enter, Git replies with all the commits that are part of this repository. It starts with the commit ID, and then we have commits and identifiers. After the commit identifier, we have the author. It's me, followed by the date and then our commit message. In this case, we received our multi-line commit message that we have entered by using our text editor. We can get similar information by using the git show command, like this. And it displays the last commit and the diff containing all the modifications. We are going to edit an existing file managed by Git. I'm currently in my terminal in our test repository. If I run a git status command, we can see that we have a clean working directory with nothing to commit. If we type ls, we can see that we have two files, hello and Venus. Let's update our file called hello with the code command. So we type code command followed by the file name. Here we will add the short text, save, then exit. Back to the terminal, I will run again a git status command. Now, Git tells me that I have a modified file. The difference is that in the previous videos, our file called hello.html was not tracked, and that was then the changes to commit. In this case, we have a modified file that simply shows changes not prepared for the commit. This is how Git makes the difference between the untracked files and the tracked ones. To find out which file that Git tracks, we can use the git ls-files command. Git tells me that two files are being tracked, the file Venus and the file hello. If I add the file by using the command touch and the name of the file, for example, earth.html, we type ls, I can see that the new file called earth is in my file system. Git sees that I have an untracked file and the modification of the file hello.html. Type git ls-files. It always reveals that Git tracks only the two files Venus and hello and not the new one, what we call earth. Let's get rid of this file by executing the command rm earth.html. It's the bash command used to delete files. Run a git status command. Now, I'm back and I just see the modifications of the file hello. This is why I'm going through this, to show which files are tracked and that the following command relies on all tracked files to work. And that's when we use the command git commit -a. The parameter a tells Git to add firstly the modified files to the Git staging area or the Git intermediate area, and then skip to commit. We can accomplish this with a single command in this option. Now, you may ask yourself why we add a modified file. It is just the way Git works. That's why I add the changes to the Git staging area and then apply them. Let's continue by also specifying our m parameter that we can combine into a single parameter, so we have am. So type git commit am and the name of our message in quotes. For me it is update. The commit is finished. If we type git log, I have now two commits, the most recent and the other one. We are going to cancel some of our modifications by going through the Git staging area and then going back to our changes. I started my terminal in the test repository. We are on the master with nothing to commit in a clean working directory. So let's start. I will edit the file. We will access to our files by typing code, then the name of our file. Here I will put a short random text that will be cancelled. I get to the next line. I save, then I close. I will run a git status command. Back to the terminal, we can see that our file called hello is modified. I'm going to add it to the Git staging area by executing the command git add _ all like this. Now, if I run a git status command, we can see that our file has been modified, and if I decide that I really don't want these changes, so what I could do to remove these changes is running the command git reset and the special pointer head with capital letters and the file to unzip. In our case it is hello.html. So we type git reset head hello.html. Then press enter. Git replies that the steps have been reset. If we open our file named hello, so we type code hello.html, the text is still here, but the modification has been cancelled on Git. Back to the terminal, if I run a git status command, it shows that we have a file that has been modified. But I don't want any of these changes. To ignore completely these modifications, I'm going to go back to the last known state of this file that is found in the Git repository. To do it, we are going to execute git checkout command. So we type git checkout _, then I leave a space, then I type the file name. Let's check if this has worked with the git status command. We are back in a new working repository. What about the file? So we type code hello.html .inspect the file. We can see that our last line has been removed. Our modifications have disappeared. We will manipulate a little bit more git log command and then set up a git alias to create a shortcut for a command. In my terminal, I'm currently in my test repository. I'm on the master branch with nothing to commit, as I have a clean working directory. If I type the standard command git log, I see that I have two commits. However, if I use the git head command by typing git head log, I see that there are many options that are provided to me. I will exit git head log. I already know the options I want to use. So let's use the command git log 2 dashes 1 line that will provide a simplified commit input, providing a lot of this information on a single line instead of several lines. We will add 2 dashes graph. A graph is a graphical representation of the commit history. Then 2 dashes decorate that will tell us which commits are part of which branches and other labels in the Git repository. And then finally 2 dashes all that will provide the history of all the branches available on this repository. We have now a radically different view of our git log command. Although Git has not officially history commands, this does not prevent us from creating them. We are going to use git alias to do this. To create a git alias that is essentially a new command that is a short representation of a longer and an existing command, we are going to use git config command. So we type git config double dashes global alias dot hist, which will be the name of our command for this first example. We will open the quotation marks and we type log 2 dashes 1 line 2 dashes graph 2 dashes decorate and then double dashes all. The syntax and config double dashes global because we want that this alias to be at the user level, not at the repository level. Then the configuration key, which is alias, and the name you want to use for your new command. In my case, it is hist. After you have typed your commands, press enter. We can check this input by listing git config inputs with the command git config double dashes global double dashes list. And at the end, just here, you can see our hist alias. So now let's test it. To use an alias, you have just to type git and the name of your alias. In my case, it is hist. So we type git hist. If you have succeeded, you must have the same result as the log command that we have seen before. Using aliases does not prevent you from passing additional parameters to the command. For example, git hist double dashes hello.html. Hist will pass only my file hello.html with the hist command. Hello, in this video we are going to rename and move files and delete them by using Git. I'm currently in the test repository on the master. I have nothing to commit since we have a clean working directory. We will start by creating a new file, so we type jupyter.html. Let's add a short text. So we will access the file by typing code followed by the file name. We will write here, for example, a title, an example. We save, then exit. Once I'm on the terminal, I can do a git status command. You see that we have a new file. Now, let's add the file by doing a commit. So we type git add jupyter.html. We carry on with a git commit -m with a message adding a file. Currently, I have jupyter.html in my file system. What happens if I don't like the name of the file? I can change it by using git commands, which provides additional advantages compared to a simple modification of the file in the operating system. If I type git mv jupyter.html, so we'll rename it to pluto.html, like this. The mv command is used to move files. We will move the file to its new name, so I move the file Jupyter to Pluto. This effectively renames the file. Press enter. No news is often good news. Let's run a git status command. Git shows that it will rename Jupyter to Pluto, but this modification is pending. If we type ls, we can see that the file has already been renamed in the operating system. To finish the task, we have to commit. So type git commit -m followed by a message. For us, it will be renamed to Pluto. In the commit, it shows that we renamed the file Jupyter to Pluto. Between brackets, we have 100%. It's the confidence level. That is to say, Git thinks it's exactly the same file. If we had made modifications to Pluto before committing, then this level would have been less than 100%. And if we didn't want this file at all, then we could remove it. Instead of deleting it by using the operating system, we use Git to perform the removal. We have an additional advantage. Git tracks automatically the removal. By doing ls, we have our file called pluto.html. Type git rm pluto.html, then the name of our file that we want to delete. Press enter. rm is used to delete files. Our file is removed. It tells us that Pluto has been deleted. If we type ls, we see that we have no longer our file pluto.html. However, if I run a git status command, we can see that our deletion is not quite effective yet. To make it so, we have to commit. So type git commit -m and the message that is deletion. If we execute a git status command, great, we are back to a clean working directory. We will rename and delete files outside of Git and see how Git responds. I'm currently in my test repository. If I run a git status command, I'm on the master with nothing to commit, since we have a clean working directory. I have two files, hello.html and venus.html. Let's create a file by using the command touch. We will call this file uranus.html. By doing ls like this, we see that we have our file called Uranus, and we are going to use the command mv venus.html, the name of our current file, and we will change it to venus.txt. This command is used to rename a file. If we type ls-l, we see that we have our file uranus.html and the file venus.txt. Let's see how Git sees this. Although Git sees the files that I have changed untracked, it's not surprising. But changing names is considered as a deletion and an addition of an untracked file. So we need to inform Git of our recent modifications. To simply have deletions, we can use the parameter -u of the git add command. So we type git add -u, which means update, and press enter. Now, let's run a git status command. We have now our modification to commit, which means that it took venus.txt, but it got back the file uranus.html. So, to include both additions and deletions, you have to use the command git add -a in capital letter. This will cover all possible types of changes on the current working directory, and therefore it will perform its updates in the git index. Now, if I do a git status command, it will see correctly venus.html being renamed to venus.txt. It also takes the new file uranus.html. Still at this stage, these modifications are only in staging area. Let's go ahead with a commit. So we type git commit -m and the name of our message, which will be rename and add, like this. And if we determine that we don't want uranus.html, we can use the bash rm command to delete files at the operating system level. So we type rm uranus.html. Now let's do a git status command. It says that the file has been deleted. Now we type git add -u. It will take in account the deletion and put it in the staging area. Now let's make a commit by typing commit -m and the message that is delete uranus.html. Now this file has We will rename and delete files outside of Git and see how Git responds. I'm currently in my test repository. If I run a git status command, I'm on the master with nothing to commit, since we have a clean working directory. I have two files, hello.html and venus.html. Let's create a file by using the command touch. We will call this file uranus.html. By doing ls like this, we see that we have our file called Uranus, and we are going to use the command mv venus.html, the name of our current file, and we will change it to venus.txt. This command is used to rename a file. If we type ls-l, we see that we have our file uranus.html and the file venus.txt. Let's see how Git sees this. Although Git sees the files that I have changed untracked, it's not surprising. But changing names is considered as a deletion and an addition of an untracked file. So we need to inform Git of our recent modifications. To simply have deletions, we can use the parameter -u of the git add command. So we type git add -u, which means update, and press enter. Now let's run a git status command. We have now our modification to commit, which means that it took venus.txt, but it got back the file uranus.html. So, to include both additions and deletions, you have to use the command git add -a in capital letter. This will cover all possible types of changes on the current working directory, and therefore it will perform its updates in the git index. Now, if I do a git status command, it will see correctly venus.html being renamed to venus.txt. It also takes the new file uranus.html. Still at this stage, these modifications are only in the staging area. Let's go ahead with a commit. So we type git commit -m and the name of our message, which will be rename and add, like this. And if we determine that we don't want uranus.html, we can use the bash rm command to delete files at the operating system level. So we type rm uranus.html. Now let's do a git status command. It says that the file has been deleted. Now we type git add -u. It will take in account the deletion and put it in the staging area. Now let's make a commit by typing commit -m and the message that is delete uranus.html. Now this file has In this video, we are going to compare the differences by using the diff command. I'm currently in the git test repository. If I run a git status command, I'm on the master and I have a clean working directory. I'm going to use my new hist alias to display my history. So we type git hist. If I want to see the difference between two commit points, I can use the git diff command. I will select the second commit from the bottom, and for the second point, I will use the special pointer head. So I type git diff 869 e 160 and our pointer head. Then press enter. Now we get a difference between head, which is last commit of the current branch, which is the master, and the specific commit. We could use the same command except that instead of typing diff, we type diff tool. With the same parameters, we will also launch the diff tool configured in my case with p4merge. Since several files are associated to this diff, I will browse each of them by exiting p4merge with the command Ctrl+W in order to move to the next files applied in the diff. Once we have browsed all the files associated with the diff, so this one and this one, by doing Ctrl+W, and this sends us back to the terminal. I will modify the file hello.html, so I type code hello.html. Here we will write small modification. I save and then I close. I have saved these changes and now I know that the file hello.html is modified, but I don't know what these changes are. So let's do again git diff. If I type git diff, I get a difference between what was recently changed in the working directory and the position of head in the repository, which is last commit on this branch. So you can see the differences, and I have a small modification just here. So if we type git diff tool like this, we do the same thing, but we have to use p4merge instead of head. Here we have it. Once you have finished examining the differences between head and the working directory, exit p4merge by using the command Ctrl+W. The diff command is actually extremely powerful. You can type git help diff like this. I recommend that you check the page of head for the diff command. There are many options. And foremost, everything that can be passed in the diff command can also be passed in the diff tool command. Branching and merge are important concepts in Git. Git facilitates the creation of branches and merge than previous tools, and therefore many workflows depend on it. As we have discussed before, a branch is just a commit timeline. More precisely, branches are names or labels we give to a timeline in Git. We can create and delete branches without affecting timelines. All we do is creating or deleting labels in the Git commit. Until now, we have worked by default on the master branch. Now we can create a new branch to do some work and then join the master branch by merging all the changes that have occurred on the new branch. While merging, Git tries to merge automatically when possible, which leads to several types of possible merge scenarios. Firstly, the fast-forward merge. This happens in the simplest cases, when additional work has not been identified on the merge branch, or in our case on the master branch. Git will simply apply all commits of the other branch directly on the main branch as if we have never done a ramification. Obviously, we can disable fast-forward merges if they are undesirable for any reason. Secondly, the automatic merges. This happens when Git detects non-conflicting changes in the main branch. Git is able to automatically resolve all conflicts by using the history of the old branch, and a new commit of merge is created to show the merging of both branches. Thirdly, the manual merge. This happens when Git is unable to automatically resolve conflicts. Git enters in the merge state into a special conflict, which means that all merge conflicts have to be resolved before proceeding with the commit. Once all conflicts have been resolved, these modifications are saved as a merge commit. In addition to tag branches and other labels for commits, Git has special labels or pointers. A popular pointer called head, and normally it's the last commit of the current branch. This means that when we change branches, the location of head moves. To match the last commit location of this branch, although this is generally true, it's also possible to manually move the location of head elsewhere than in the last commit. We will deal with this in the advanced section of this course. For now, head points to the last commit of the current branch. We are going to create and manage branches other than the master in our Git repository. I'm currently in the test repository, and in the previous video, we have a modified file called hello, and maybe we wanted this file to be modified in an experimental way or as a part of a feature of a next update. In both cases, we can use branches, so we type git branch. With the git branch command, we can see that we have only one branch named master. And for the moment, it's highlighted in green and followed by an asterisk. An asterisk that shows that this is the current branch. Now, I could create another branch by using the command git checkout -b, and we are going to call this branch test. With this command, I create a new branch with the parameter -b. The checkout command allows me to go directly to that branch. Test is the name of my branch, and the modifications that were pending in the working directory have been transferred to this new branch. This is a technique that you can use when you start working on the master, and later you decide before committing that these changes be really isolated in their branches or sections. Let's go ahead. We type code hello.html. We have our text here. I will just add here this phrase on a branch I save, then I close. Back to the terminal, we will add these changes by doing git add and a dot. And now let's do a commit. So we type git commit -m and our message, which is add update from a branch. I run a git status command. This shows that I'm on my branch called test and that I have a clean working directory. If I type git hist, it should be said that we have the last commit that is at the top, and that is test. But if we go back, we see that this is the commit to which the master has been associated. We can see which these changes are by using our diff command. This command will allow us to go through the names of the branches instead of the commit identifiers. So I will type git diff test master, and this shows us what's different. So, saying that I have finished with all the updates that I needed on the test branch to integrate the changes made to my branch, firstly, I have to switch to the master branch. So, I will type git checkout master. In order to change a branch, we use the checkout command and the name of the branch. Now, let's look at our history from a master perspective. We type git hist. This shows again that head is now on the master. Since head usually means the last commit of the current branch, and since the current branch is the master, so head and the master share the same commit identifier. As our hist command specifies the parameter to-all of our log command, we will also notice that the commit ID is associated to the test branch. So let's go ahead by doing a merge with these modifications. Type git merge test. We write test to indicate which branch we want to merge. Concerning the merge, it is a simple merge, and it is so simple that it allows to perform a fast forward, which means that we will pretend that you have never really passed on the master to perform these updates. Therefore, we will apply these commits directly on the main branch. Now, if we type git hist, we see that head, test, and master all refer to the same commit ID. This is the effect of a fast forward merge. There are options to disable fast forward merges, even if they are possible, and you usually want this behavior. Once we have merged our changes, we no longer need the test branch. The branches in Git are timeline labels. Once they are integrated in the main timeline, they are no longer necessary. So for this, we will use the command git branch -d. D refers to delete. We leave a space, and we type the name of our branch, that is test. Now we are going to execute again git branch command. We have removed this branch, we are back on the master. If we type git hist, we see that the update branch is no longer associated to this commit ID. We will follow the necessary steps to provoke a conflict, and then resolve this conflict when working with branches. In my terminal, I'm currently in the test repository. So here, if I run a git status command, I'm on the master branch and I have nothing to commit, as I'm on a clean working directory. I take a look at our file called hello on the master branch by typing code hello.html. So we have our updates that have been integrated from our previous example. We can close the page. Let's create our branch on which we are going to work. We type git checkout -b Jordan test. Now you can see that we are no longer on the master. Let's run a git branch command. So we type git branch -a this command shows us all branches. We see that we have the master branch and the Jordan test branch. At this moment, the Jordan test branch is our current branch. We are going to modify our file called hello. We are going to do it in such a way as to create a conflict, which means updating the same part of the file on both branches. So I change this line to this is a conflict. We save and close. We type git commit -am followed by the message that will be run update. I will use the technique of fast commit by saying that this is a run update. We type git haste and we have our commit at the top, which is the last commit. We will go back to the master by doing git checkout master. We will go back to the master by merging these changes. I will pretend to be a developer, or maybe I will just forget about these changes that I made on the Jordan test branch. We will type code hello.html. We will just replace this by this phrase, this is a possible conflict. We save and we close. Back to the terminal, we will do again a fast commit. So we type git commit -am and our message, which is run update again. Now we will do a merge of our Jordan test branch. In the master branch, we will type git branch -a and we type git merge Jordan -test, and as expected, the automatic merge did not resolve the conflict. The automatic merge is very good, but it's not perfect. It doesn't know which file version we want. This places us in the merge state that is indicated by our command prompt with the name of the branch on one side and merging. The file hello.html is a file involved in the conflict. If we open the file and display it, it only shows the entire content of the file. The current version contains these signs that indicate the parts of the file in conflict. And you can see that head is opposed to Jordan test. Since this is a simple case, we can modify this file manually. We have a merge tool configured with Git, so let's use it. In this merge state, just type git merge tool like this, and before merge starts with a 3-step merge. And we can see that we have different versions of our file, and the possible solution is on the bottom. Any of these solutions are possible to be incorporated. Saying that I want this one, once I have finished, I have to click on the button Save to validate the modifications made to the file hello. Now, once I have finished this, I no longer have conflicts. I can exit before merge by clicking on the button Save. If there are no more files with the merge conflict, you can go back simply to the command prompt. To finish the merge, we need to commit what we have saved. So we type git commit -m and our message, which is a resolved conflict. If this resolves the conflict, you will be sent to the command prompt that seems normal. In this case, we go back simply to the name of our branch, just here. If we execute a git status command, we can see that we have an untracked file called .org. And this file called .org is the original version of the file hello. I don't like the .org files lying around in my repository. I could accidentally add my repository. Let's add this to our gitignore. So we type code.gitignore. Just here at the bottom, we will add *org to refer to all org files. Save and close. Now we will execute a git status command. Let's make our fast commit. So we type git commit -am update ignore. Then we do ls. We still have the file .org. So I will remove it by doing rm and the name of our file, which is hello.html.org. And we have finished. We are going to examine git tags. I'm currently in the test repository. I'm on the main branch with nothing to commit. If I type git hist, we can see that we have several commits that are part of this repository. And at this moment, we have been working with the repository for quite some time. So I would like to mark this point in the repository with other important steps. To do it, Git supports a notion of size. Tags are just tags that you can put at any commit point. By default, if you don't specify a commit, it will be the current commit or the head. So type git tag followed by the name of my tag, which is my tag. There are two types of tags: lightweight tags, to which you can just give a name, and git response. If we do git tag list, you can see that my tag is listed. Also, when we execute our command git hist, we see my tag. Now we see that this is a light tag. There is no information associated to this. What I prefer to use is what we call annotated tags. That is to say, what additional information is associated to a tag. So, before we do that, we delete my tag. So we type git tag -d. D refers to delete, followed by the name of my tag. Great, we have deleted this tag. If we use the syntax git tag -a to annotate tags, then the name of the tag, for example, v1.0, then -m for the message that is in quotes, which is version 1, we actually associate a commit message to this tag. And generally, no news is good news. We will type git tag -list. So we have v1.0. Now we are going to do git hist. And we see our tag v1 mentioned in our commits history. But until now, we haven't seen anything different from our light tag. Where does the annotation come from? So, if we use our command git show, and we specify the name of the tag, so we type v1.0, it shows us that we have our tag v1, the tagger who is me, the date on which it was tagged, the commit message in quotes associated to this tag, followed by the rest of the information related to this commit associated to this tag, including its own previous message. This is very useful when you try to note important steps and you may want to associate information. We will take a look at the console line. We will execute a git status command. I'm currently in the Git repository, on the branch in a clean working directory. Let's edit the file hello.html. Here we will add a small paragraph, just one sentence. We save and then we close. If we do a git status command, we see that we have a modified file, but what happens if we decide that we are really not supposed to do it now? And if we decide that we should have started this on a branch, or maybe should we change the content and work on something else for a moment? Well, we can do it by using git canceling capacity. So let's do this. Type git stash like this. It tells me that head has been saved, which is the last commit on the current branch, that is the master, and that saved it in a work in progress. If we do git stash list, this shows us our stash. We have a whip on the master. It shows us the last commit and the associated commit message. We will execute a git status command. After the stash, we are back on a clean working directory. We will open our file Venus. Let's apply our emergency solution if you want. Here we will write v.3 for the third version. We save and then we close. We are going to do git commit -am followed by our commit message, which is updated file Venus. This will be considered as our interruption with which we have to deal. Back to a clean working directory. Now let's apply our stash. We type git stash pop. So this will make two actions at the same time. One is applied, then the next is deposited. The applied stash will apply regardless of the stash. It's the last stash. In this case, we will restore its changes in the file hello, and then it deletes the applied stash. If I do git stash list, I have no results. If I type code hello.html, so if I come back to my file hello.html, you can see that the file hello has been updated before the stash. Let's go ahead by committing our update. We will do git commit -am followed by the commit message, which is update hello again. Then we will run a git status command. You come back to the empty work directory, and we have finished. We are going to travel back in time with a reset and reflog. We run a git status command. I'm currently in the test repository and I'm on the master branch. I have nothing to commit because I have a clean working directory. So we will deal with this. I will open my file hello by typing code hello.html. On another line, I'm going to type updates in the staging area. I save, then I close. So I'm going to do git add and the dot. Then I will add another line by reopening our file hello. To indicate our modifications that we have in the working directory, we will write here a new paragraph, for example, updates in the working directory. We save, then we close. If we run a git status command, we see that our modifications are detected both in the staging area and in the working directory. Now, it may happen that you have to use a different commit point. For example, if you made a mistake in the last commit, you do not need this commit. You want to come back to a previous commit, it's no doubt a good idea. So, we type git hist. You can see that we have several commits to choose from. So, I will type git reset followed by my ID, which is 7cc0341, followed by two dashes and soft. So we'll do a git reset. I transmit the commit identifier to which I want to come back and the option two dashes soft. And the reason why I'm doing it is that there are three different ways to reset. There is a soft reset. That's what I'm about to do. There is a default value called mixed, and then hard reset. The soft reset is the least destructive of all reset modes. Basically, all that it does is change the place of head. Usually, no news is good news. Note where head is found right now. We will do git hist. As expected, head points to the other identifier, that is the commit identifier we transmitted to the reset command. Let's check with our git status command. We have files that have been modified and they are in the staging area. What the software allows us to do is simply to change the commit ID on which head points, which means that it preserves the git staging area and our working directory. Indeed, we can cancel our modifications, including minor modifications, then commit to the place pointed by head. Let's try this one more time. I will choose the commit ID, so I will choose this one. We are going to do git reset followed by the identifier, which is A88 AC88 followed by 2 dashes and mixed. And although mixed should be a default value, there is nothing wrong in just specifying it. To be sure of our example, we go ahead by pressing enter. What's interesting is that the number of changes has not been indexed. If we do git hist, we can see that head now points to add in the ignored file. If we run a git status command, we will have several files that have been split and placed in our working directory. There is nothing in the staging area. Let's try this one last time. Now type git reset followed by the identifier. We will choose update, so 869E160 followed by 2 dashes and heart, and then press enter. It's the most destructive of all the reset modes. It just tells us that our head is in a new place. If we execute a git status command, we see that our working directory is now empty, which means that all pending modifications have been deleted as well as all that was found in the staging area. Here again, a hard reset is the most destructive reset mode. But apart from the few modifications made at the very beginning, we have not really lost much. If we do git hist, our head is now directed to our second commit history. If we do git log, 2 dashes, 1 line, like this, that is to say we put 2 dashes all, we see that we only list 2 commits. So if you see this history list, then you might be a bit worried. It's not a big deal, as there is another command that we can use together with the reset one that greatly improves things. It's called reflog. So we will do git reflog. Although gitlog and gitreflog share similar names, gitlog displays our commit identifiers, and gitreflog shows us all the different actions we have done in this repository. This allows us to come back to one of the specific commit identifiers if we need it. For example, let's move to head 3, which is the last commit before any reset. I will choose this commit identifier and do a git reset. So I type git reset, 2 dashes, hard, followed by the identifier 829C993. At this stage, since there is no pending work, we can leave it by default or specify hard, then paste our commit ID. Now we move our commit ID. We type git log, 2 dashes, 1 line, like this. It looks like our history is back. By using our alias git hist, we can see that our git history looks like the repository before the reset. Using reset and reflog really allows you to fully control time travels in your Git repository.